Okay, so yeah, it's Sunday, very early, so thank you for being here for my talk, how to reduce cold starts for Java Serverless application in AWS. We will cover GraalVM native image, AWS SnapStart, and core. But first of all, the question is, who is of you is Java developer familiar with Java? Okay, that's good. Sometimes we are .NET people. Okay, it will be very difficult. Who has a knowledge of AWS or in general? Okay, a bit. Okay, then a bit of, and of course, then serverless is probably also something new. Or are you familiar with the concepts with other cloud providers? Okay, but yeah, it's not the general talk about serverless, but how to adopt serverless, especially for Java developers and especially on AWS. There are some similarities to other cloud providers, but now with AWS SnapStart, it begins to, just to move away. So these are kind of AWS own services. But nevertheless, I would try to explain or ask questions just that I can explain you. So my name is Vadim. I'm Ukrainian native, but just more than half of my life in Germany. I have these two passions, AWS Serverless and Java. I'm one of the co-organizers of Java user group in Bonn, just around the corner, and I live here near the Bonn area. So this kind of, I have home advantage kind of here, just for the 8th time in the row. And I'm also AWS community builder, where I also kind of share my knowledge about AWS services, and I'm also just in the AWS serverless category. So that's why also this talk, just combining that stuff. So I'm quite active on Twitter, but you can drop me a message. I'm easily found to be found everywhere, and so on. Only several words about my company, just also founded in Bonn. Probably you heard about Frank Thelen, Höhle der Löwen. He was one of the investors here. That IP Labs was founded by him 2004, I think, and then that was one of his first exits. He sold us to Fujifilm Europe and then left the company. But what we are doing is just software for designing and purchasing of the photo products, like calendar of the year, photo book of the year, so prints, posters, so everywhere where you can just print the photos, more or less, your photos to some kind of product. And we finished we started this, I started 17 years ago as a Java backend developer mainly, and I developed Java since 98, something like this. And we were in the data centers, but we finished this more than 1 year ago. We completely switched to AWS. It took 4 years because we had different data centers with different models around the world, and it just took time because very difficult operational model. Sometimes we were responsible, sometimes it was shared responsibility with one of the Fuji customers, and so on. But we switched to AWS more or less per lift and shift, but then we started just to refactor to gain value of the cloud itself, and now we are doing more serverless stuff, or at least try to be serverless first. And then we see if it just doesn't fit, and sometimes it doesn't, then we can go like containers or something like this. What we don't do is Kubernetes, just a bit of complicated for us, for our use case, but there are lots of successful companies doing that. So it's more about, So this was kind of just to give you a reminder, Java is really very good programming language with a very strong community, so many conferences, so many open source projects. I'm not aware about how it's working for NetWorld, but I would say just Java is really brilliant. And depending on where you look for the rankings and how they are collected, it can be just number of GitHub projects, number of job postings, or something like this. Very difficult. You will see that Java is between place 1 and place 3, and this is constant for the last 20 years. And I think that depending on the ranking, the gap between Java and the place number 1 is just marginal, more or less. But when we will look into the Java world, serverless world on AWS, luckily we have now since 3 months support of Java 17. Which was for Lambda, for serverless services. It took 2 years that they provided this support because they only supported Java 11. It was kind of, if you have now Java 19, then only having support for 11 was not very lucky situation now. Since 2 years, 2 months or 3 months, we have Java 17, and AWS provides its own distribution of GDK. It's Amazon Correct. This is like OpenGDK or Adopt GDK. So this is kind of their fork. They still support Java 8 for good or bad until 2026. They promised that they will support Java 8. So it knocks you down that you say, I have 2 years more to migrate. And we are still in that hell partially at AP Labs. But at least now they support 17 and all that stuff. And they patch also the security situation. So yeah, Java is very fast programming language, but Java serverless adoption, we see how many Lambda functions, and we will look into Lambda is kind of in the heart of AWS serverless services where you run your business logic or write business logic. You see that the Java adoption is just, it's the statistics from 2 years before. I would say it's in best case in the very beginning of the double-digit adoption. Yeah, that maybe 10% now, and we see Python, Node.js, all these JavaScript derivatives quite above. And this is very unlucky situation for the community, or it has been for years. Our first serverless project with Java was written 4 years ago when we ran into all the problems that I will be talking about, and there were no solutions 4 years ago. Now it's starting to go that way, but for example, we at AP Labs, we switched also to writing lambdas in TypeScript and Java languages as well, just to go around. Now there are solutions. Now we can, I think Java developers are more comfortable developing now. So what's the problem with that, or what's the main? There are several, more or less. We will be more talking about the first one, this cold starts. There's also memory footprint, which is also a factor of cost on AWS, but it hurts you kind of not very much. But now let's look how we... So the question was if this 10% is running with all the problems. Nobody can tell you, because you have now the possibilities to optimize. And nobody can tell you. I think that the people will optimize for one or another decision things. And sometimes the latencies are not the problem, because if you have asynchronous workflows, then this cold starts. It's just not a big problem. So sometimes you can say that just okay. Yeah, nobody is waiting for the response. It was also our first application with Java and serverless. They had really heavy cold starts, but it was the calculation for our finance department, which ran heavily for all customers on the first of each month in the night. Nobody cared. The thing was that the project manager wanted to have numbers as soon as he is in the office on the first day in the month. It can be even 2 days later, because it's Saturday and now he is on Monday. He wanted to look into the email, so latency didn't matter. But there are, of course, public-facing applications, and then it's different. So several basics about Lambda, how you write it. And so first you select your managed language, programming language. In our case, we will, of course, select Java 17. We will also give the name to the function, and we also can select the architecture. So the default is x86, but there is also AMD, ARM architecture, which is a bit cheaper, but you need to test your workflow. And what else you need to select is just the memory. Yeah, you can give your function between, I think, 128 megabytes until 10 gigabytes in 46 megabytes steps. It's up to you. And the CPU will be given to you based on memory. So you cannot tune it. For example, you will have the full CPU access if you have selected 1.8 gigabytes of memory. So if you select half of the gigabyte, you will have 1/4 of the CPU core for this. And the same is for the network bandwidth. Yeah, just the only one thing that you can really configure is just memory, which is also kind of. So there are more or less, there are more, but generally there are two possibilities to write Lambda function, where you write your business logic more or less, or where the Lambda receives event from the API gateway or something like this. On the left side, you use AWS SDK for Java, and more or less you implement the request handler interface. Yeah, and the only one method, handle request. More or less, you get the request, and then you give back the response. And on the right side, it's just pure Java 8 functional programming. Yeah, you just implement apply interface. There is no dependency to AWS SDK, nothing. It can be automatically recognized kind of as a Lambda function if you have only one method. And this method kind of receives request and response. The only one difference is on the left side, you see this. The third parameter of this function is context, which comes from AWS SDK. It gives you some additional stuff. I personally use that. It's preferable for me because the logger is injected. I don't need to do this. And on the first method is get remaining milliseconds. You have timeouts on the Lambda function. Maximal is 15 minutes, but probably you will have something below because you just don't want to pay for that, and you will have something like 30 seconds that if you run out of time, you can kind of log after several operations how many milliseconds are left until the timeout. And then you can quickly figure out how much time did what operation take. And so on. That's my preferable way, but you can use the another way and inject the logger as well. It's just not a problem. So now this challenge number one, the call start. So what is that? So people who are using more or less containers or Tomcat on Neo web application server know that you can process multiple requests with that. And if it just cannot, you start another instance. The function as a service works differently. The container is only able to process one request. It's like pool, and it cannot process more. So for each request, you need the new container. And that means that this call start happens if there are no containers there. It may happen if you write the function and deploy it for the first time and you would like to invoke it for the first time. There is no container which is ready. It needs to be set up, and we will look what does it mean to set up. Or you have, if the container finished its work, it comes back to the pool, warm pool of containers, like JDBC connection. Yeah, we give it back to the data source pool. Yeah, the same is with containers. But sometimes, for example, you have 2 containers there, but now you have 5 requests in parallel. So you are missing 3 containers that they need to completely initialize. This is the call start, completely new stuff. And this is how it works. Like it will, when the request comes in, it will be just looking for if there is a warm container. If no, then the new one should be started, and then you have this call start. So this is exactly what it means to have this call start. First of all, the container need to download your function code. Yeah, just your Lambda function, and it's stored in S3. Then a CRaC VM needs to be started. This is the container in AWS world. This is their native implementation. You can think about it like Docker container, or Kubernetes, which orchestrates that. AWS uses its own implementation. It's CRaC VMs. Yeah, and then AWS Lambda needs, in case we selected Java as an executable or as an environment, then Java starts JVM. Yeah, it also should be started. It's just nothing is pre-warmed. And then in this function handler, what we saw, then the static initializer block of the Java function needs to run. So everything outside of the handler function itself is static initializer block. And as we know, that everything needs to be initialized recursively. All the dependencies should be loaded that are available outside of the handler. And this is everything is just what I told you is more or less the call start. And very important in the static initializer block, you have one CPU. It doesn't depend what memory you selected. In the static initializer block, you always have one CPU up to 10 seconds for free. So you can optimize the stuff in this static initializer block. Yeah, only 10 seconds, but normally it's more than enough. But it's for free in the managed environment. That's important. And then the handler method will be called. And this is the warm execution. So in case the container is there, the warm container is there, only the handler method will be called. Yeah, this is the warm start. And in case there is no warm container, you will go through all these steps, download your code, start new execution environment, this CRaC, this Lambda starting JVM, and then a static initializer block will be executed and all that stuff. So probably what happens with the warm container? So I told you when you need the warm container, the first execution, or there are no enough containers, like you have 10 in the pool and now you have new sled and then 1,000 people click, and just there is a gap, so they needs to be started. There is a third one, AWS releases the container from time to time for security reasons, that the container doesn't stay forever. They patch it and so on. They don't publish how often it happens, but from their you can track the container ID. If you execute and then you see after, I would say 2 hours at latest, the container will be released anyway. Yeah, whether you use it or not, and then probably you will run into the cold starts. For example, if you just do 100 executions, you will have in the end 100 warm containers. If you come 3 hours later, they are all gone. For security reasons, they will be patched, and then the new execution environment will be executed. Once again, please.
Do you still get the same response time when they restart the container, or will we see a gap in response time?
You will have the cold start with a new container, and it will be bigger. I will be talking about this. Yeah, but generally there are the container. So the question was, will I see the difference in the response time if the new container will be started? You will have the cold start, and it will be just the overall response time, and I will be talking now about this, will be bigger. So there is no much difference. Of course, there are variations. No two containers starts with the same amount of milliseconds, but they are kind of comparable. But the difference, we will be now talking about the cold start and without cold start is noticeable. So, now I know that not everybody is expert in the serverless, but nevertheless, this is kind of typical serverless application. You have API gateway where the request comes in. Or many requests, you have bunch of Lambdas. This is kind of similar to our application. We have serverless application for creating the products in our deleting, editing the products, photo products, and we have DynamoDB. Just we can forget it, kind of NoSQL database. It doesn't play a major role in this talk, but this is the typical stuff. Everything is serverless. And now we will see in the cold start, what are the numbers of the cold start phase. And these are best case numbers. You see with the pure Java, you don't have any framework, P50, so in 50% probability you have kind of between 3 seconds and 4.5 seconds. And P9 can be bigger, and if you're just using the frameworks like Micronaut, Quarkus, Spring Boot, it increases because Spring Boot is heavy because of these reflections and all that stuff that loads in the static initializer phase will be just heavy, loaded with all this annotation processing and all that stuff. Quarkus and Micronaut are not that heavy, but of course it's just the abstraction over the normal stuff, and it adds also. And this is only cold start. Yeah, so you will need to add to this the warm start, the function execution itself. It can be very quick, 10 milliseconds. So, but what it adds also, the request should come in through the API gateway, and then the response should come back through the API gateway, and then the client need to render the results. Yeah, client like web page. Yeah, and if you add this, then it can be quite noticeable. But the message here is only the cold start itself adds several seconds. Yeah, when the execution itself can add 10 milliseconds. And if you have public-facing application, and the cold start happens probably 1% of the time that you don't have the warm container, but if you have 10,000 executions 1% of the time, then 10 users will have that amount of waiting time. And you know probably these studies from Amazon, everything after 1 second, you just can lose the customers. And depending on the application, it may bite you. Yeah, and these numbers are kind of also optimized numbers. We will go through that optimization. So my first cold start was over 20 seconds. I didn't know about optimizations 4 years ago. We just simply wrote Java, Lambda with Java, with the same architecture, more or less. Didn't do anything in just 20 seconds. Okay. Yeah, and the people using Spring Boot, and they say, our company developed with Spring Boot. We are very productive with that. Let's try it with Lambda. They have this cold start. They shut down and say, just no way for us, or said until 1 or 2 years ago. And this is kind of real situation. Nobody can live with the Spring Boot cold starts in case it's public-facing application, at least not for that. So let's go for some best practices that you need to do anyway, more or less. So this SDK, you have the older version of AWS SDK to talk to DynamoDB, other services. Use this newer one, it's just modular, and it gives you the possibilities to include or exclude the stuff. The old one included all the services that they were. There is also, in case you prefer asynchronous communication with services like DynamoDB and so on, AWS released its own HTTP client, asynchronous HTTP client. And for example, DynamoDB uses HTTP client. Underneath an HTTP client, for example, like native, like Apache HTTP client, they had that disadvantage. It relies heavily on pre-initialization and caching because they are more for the container world or the long-running applications world. So they trade off 1 second time for initialization the stuff only once. But for the serverless world, it's not. For short-living functions, why should you pay for something is done once if after 2 hours the container is released? You don't have the advantages. So that's why AWS optimized a bit for asynchronous stuff, but this not everybody would like to use asynchronous API. Yeah, it's a synchronous client. You need all of the stack to work asynchronously to have the benefits, because if you don't render the result asynchronously, or you use relational database and talk to it synchronously, then you don't have any benefits. Yeah, just it will be blocking. So another stuff, yeah, with that, you can only include with the Amazon SDK only dependencies that you wish. So you don't need to have everything there. Also, the artifact size matters. So I know that people running application on Tomcat, yeah, we add dependencies like a hell and just don't look, do we use them or not? We're just loaded from other dependencies. So the situation is here, very difficult graph to read, but it says the bigger the artifact is that you deploy, like Lambda code with all dependencies, the higher is the cold start. Yeah, it needs to be downloaded from S3, each byte costs you a bit of milliseconds, but also just to load, and then all these classes need to be loaded. So simply put, you need to take care of dependencies, only put what you use, and try to exclude the stuff that can be kind of dependency from dependency. You can exclude that. If you don't need it because some cool frameworks brings you everything, just that you don't need that. So other stuff is, it's very important. So if you deploy Lambda function, or in the Lambda function, you talk to some other AWS services in order to build the client. And this is kind of Amazon DynamoDB client. I want to talk to DynamoDB table. The very important stuff is this with the region. So AWS can figure out where you deployed your application and what region, like Central 1, Frankfurt, or EU West, Ireland. But it takes 700 milliseconds. You can, with a builder pattern, give the hint where you deploy, because generally you know. In our case, we deployed it's only one region in AWS anyway. So give the information that you need, that you have, just will save you also several hundred even milliseconds. Another stuff, I told you that we rely heavily on this static initializer block because we have the full CPU core for 10 seconds for free. So that's general best practice, I think, for Java developers. Put everything that can be reused outside of the function in static initializer block anyway. And for example, this initialization of Amazon DynamoDB client, it can be other services from AWS. You initialize client once for Lambda function. So put it outside, you have the full CPU, so it will be initialized in general faster. And just you don't need to initialize the client during each Lambda invocation. Just waste of time. Okay, another stuff that you probably close your eyes, but it will become important in the end of the my talk. There are some dirty tricks to do that stuff, but you need to be aware of what's happening. For example, if you do the DynamoDB client, initialize, and then call it for the first time, like you would like to get some item from the table, my table. Like there are products and you would like to get the item with no matter what ID it is. In this case, as people know that DynamoDB uses JSON for serializing, deserializing, on marshalling or unmarshalling, JSON to object and back, people know that this JSON marshal initialization costs you 1 second. Yeah? And it's only one-time stuff. just to preload the dependencies. It only happens once for the life cycle of Java function, but you need to know that it's costly expensive operation. You can do fake call outside of the handler block with, for example, get ID 0. You are not interested in the result. You are interested in pre-warming to save you time than the execution. It's a dirty hack because it adds some code, but it will be important further. But you need to be aware that you can win in case, for example, your Lambda function has much less memory as 1 gigabyte, then you can speed up things. And probably one of the best optimization, I left it until the end, is people love just-in-time compiler. Probably you know there is client and server compilation in Java, or C1 and C2. The first one is client, it's just not very aggressive, and the second one is server compilation with all that optimization, inlining, loop optimization, that code throwing away. But the situation with the C2 compiler or server compiler is it mainly kicks in after 10,000 invocations of the function. This is the default value, how just-in-time compiler. You can lower that, but you probably will miss some optimizations. The situation is it's very unlikely that one function will be called 10,000 times. The container will be released or something like this, or you will redeploy. Only several functions can benefit of this. That's why you can add these parameters that you stop optimization at level 1. You see here exist stop at level 1. With that, just-in-time compilation will be kind of excluded. Yeah, so this only client compilation happening. And for server compilation, it's just not for free. There is a thread that is doing the job in parallel. This thread takes time and CPU resources, and also memory, for which you will also pay. If you just say, I don't need it, you save on this, and you will probably not benefit. So you will probably trade a bit of cold start. It lowers the cold start, and probably the warm execution will be a bit slower, but you will not notice it in many situations because you will not have any benefits of 10,000 invocations. But nevertheless, what serverless does, it reverts all best practices more or less, or how we developed before that. So in general, you need to avoid everything that is just like reflection, runtime, bytecode generation, proxies, dynamic class loading, everything that Spring is built upon more or less, yeah. And of course, then the people say, yeah, but I used that and it worked. Yeah, it worked for the long-living applications, but serverless functions are short-lived. And this is, of course, the situation where we since years are. And now let's talk about the solutions, because I showed you all these optimizations, but only if you apply that, you will get this 3 seconds cold start. Without it, you will have more than 10. But even 3 seconds cold start is just not acceptable anymore. So you need generally also other solutions. And yeah, with Graal VM, probably everybody knows what it is, but what's interesting and what's relevant for us is this substrate VM, which is optional on the Graal VM, and it gives you this native image capabilities. And native image capabilities is based on ahead-of-time compilation. And ahead-of-time compilation is obviously kind of closed world assumption. You want to package everything which is reachable from your application from the beginning. All method fields, classes, everything you would like just to put together, and then you can do kind of native image and deploy it to the cloud provider, native image. So Substrate VM supports all native images, like also Windows and also Mac. First of all, but and of course, this native images, it helps you with the cold starts because everything is there, and you can also pre-compile stuff in pre-initialize stuff, and it's also because it's compiled to the native code. It's just from the memory execution. You don't have this JVM and translation layer anymore. So this is generally good stuff, especially for the serverless world. But the question is, yeah, AWS doesn't support GraalVM and not native image. Native image is kind of routine upon the GraalVM. So how you can deploy your application into AWS using GraalVM native image. And for this, AWS provides kind of custom runtime support. It's just not Java 11. You can select custom runtime. And with that, you can package. There's a specific package format. You need to deploy kind of function zip. And with that, you need to package kind of bootstrap file. And bootstrap, in this case, is this native image. So you build a native image, package this into function zip, select this, the runtime, and then you can deploy it. And of course, with that, I will not be talking about very deeply about this, but there are frameworks that supports GraalVM native image out of the box. Spring Native, kind of, that came from Spring itself. They realized that just not the normal Spring is not for the serverless world, and they rewrote some basics and also gave you Spring Native support. There is Quarkus and Micronaut. There is also Helidon. I didn't try it. I cannot tell anything about it. But with all that frameworks, and especially Quarkus and Micronaut, they are built in for microservices and serverless application from the beginning. So they don't rely on reflection at all, more or less. And they give you the possibility to just to build a native executable within your POM XML or Gradle image out of the box. So this is more or less the common principles of that. Rely on the reflection stuff, nearly just minimize that, and they provide this GraalVM native image out of the box. If we now kind of assume that we run that, build the GraalVM native image and run this on this AWS custom runtime, you see that the cold start will be going down. You will be below half of the second, which is acceptable. Also, JavaScripts and Pythons and all that, they are somewhere there, because it's just not possible to eliminate it anyway. You need runtime to be started, code to be downloaded. It's not a free game. Yeah, but this is acceptable. If 1% of the users will have that cold start, that's okay. It's just not 3.5 seconds. And of course, there are questions, and you asked me about, what is this if I use some dependency and it just loads something per reflection, and it's not packaged, then you will have exception in the runtime. And GraalVM has this kind of library of frameworks that are GraalVM ready, that they tested and told, okay, there are no effects on the runtime behavior on this, so nothing will be kind of executed that can break my code, because it's really difficult to say in advance what's happening, because you don't control generally your application. So many open source dependencies are there that you cannot change, and you cannot even test it. It's just an update of the Spring, and that loads some dependency. It may, in theory, break something. So Graal VM Conclusion, of course, it's really powerful, and I would say solves this problem of the cold start. And I see all optimizations now. It will be even better. I think that they can reduce it even further. And it improves cold start, which is the main topic of the talk, but also memory footprint. But it's not without challenges. It's not a free lunch. The first of all, AWS custom runtime requires only Linux executable, even if GraalVM can give you Windows and Mac. But AWS requires only Linux. That means for the people not using Linux, local work is probably a bit difficult. Also, this custom runtime, you need to manage it. Yeah, you need to build this custom runtime. It's not like managed JVM that you don't need to take care of. And you need pipelines that creates this custom runtime, which creates this GraalVM native image. And first of all, it requires, on my machine, between 6 and 10 gigabytes to create native image for one Lambda function. Yeah? It's just also operating system and all that stuff. And sometimes you have hundreds of functions, so you would like to build 10 of them in parallel. So that pulls the pressure on your infrastructure. Yeah? So you need to have the CI/CD concept that can build that stuff in parallel. Yeah? And just locally will be difficult. Yeah, the next point. The question was how to. So for me, the very simple applications can take 30 seconds to compile to GraalVM native image. If I use other services like DynamoDB, which is standard, I was about 2.5 minutes for one. But you can do in parallel. But this is kind of developer experience. So generally, you will end up doing the normal Java stuff locally. But for production, you will be building. If you decide to use GraalVM, you will be just doing for production and other stuff. And this is something that disconnects a bit. Locally, it works. And then on production, you don't have a better feeling. And the custom runtime is also not the standard runtime, so you will be paying for initialization. yeah, because it's not completely managed runtime. But generally, this is kind of, these are the trade-offs. This is CI/CD. You are doing more with the custom runtime, building your own GraalVM native image. It's kind of about you. I also heard about people that say, we're using it, we are playing around with it, but we are really cautious going in production with that because of this feeling of runtime effects that you don't control. Yeah, this is something you need to be sure that it behaves runtime the same. You cannot always wait 2.5 minutes locally, and not everybody installs GraalVM and native image locally. So I think there will be improvements there that you probably provide set of tests that will be executed before something is published to production, that is, okay, the tests work, and then I can go live, because locally you will be testing without GraalVM. But there are this set of challenges, and my first feeling was that AWS will provide something like manage GraalVM native image runtime. Not Java, that will be the solution, that they will take away this old pipeline stuff and they will build it behind the scenes, that I'm not taking care of it. Of course, it could take 2.5 minutes, but it was my feeling that they will be going that step. But last reInvent in November, where AWS provides kind of, what services, the new stuff they have built, they announced something different, and it was even in the keynote. They normally didn't pay attention to Java, but now, and this was this AWS SnapStart. And in order to understand this, they split this feature into kind of how they implemented this. There are two phases, the deployment phase of the function and then the real invocation below. What they are doing in this deployment phase, when you deploy a function, they added these steps like pre-snapshot hook. This is optional. So otherwise, what they are doing, you deploy the function, but they also initialize it. So they run all the steps of the cold start, so everything but not calling the handler function. They're running through this cold start phase. This is the optional snapshot hook, and then they create the snapshot of the environment. I will be talking what is this. And in the invocation phase, the real traffic comes in, what they are doing, there is a post-snapshot hook optional. They also restore this snapshot that they previously stored, and then they execute the code. Yeah, and this is kind of, so now let's look what is that. This create snapshot and restore snapshot from micro-VM with Firecracker micro-VM. It was based on CRIO. In the next slide, I will explain what is this. And these optional hooks, they are really optional. Yeah, pre-snapshot hook and post-snapshot hook, they are based on the CRaC API. So what's this? Let's start with the CRIO for the snapshotting of micro-VM. It's even more than this, but it's based on this. This project is known, this is Checkpoint Restore and User Space. It's known since 2012 in the Linux space, and it was more or less about how to support migration of containers. That's very well fitting into this conference, open source and all that stuff. Really fascinating technology. And what they do, they're simply snapshotting everything in the environment, storing it and then restoring the snapshot. All that stuff that fits the counter, register, stacks, memory, shared memory, everything will be snapshotted. And then in theory, then everything will be restored. Then the program should continue from the same point. Of course, there are challenges, open files, but who is doing that in the static initializer block? Why should you open the file there? There are network connections that AWS solve for their own services, at least, that they can resume the connection. System clock, if you rely on this, maybe the most interesting stuff is time-based caching. If you have caching and say, I would like to store something for 10 hours and then it invalidates, nobody knows when your snapshot will be restored. It can be 10 hours later, then you have nothing. Yeah, because it stores the time of creation. Yeah, and then, or the first restores have the value, because 10 hours are not over, but then the subsequent one will be restoring it and the value will be. So we need to be careful not using time-based caches. There are trade-offs. Everything is trade-off. This is kind of this snapshot creating from Firecracker is based on this CRIO technology. But they are doing a bit more, but the basic stuff. These optional hooks, runtime hooks, are based on the CRaC. coordinated restore checkpoint. And I think this project in Java space from Azul company gained a lot of traction in the last time. This is more or less, the thing is how they thought about it, how all these microservices, they come in the same function, all this call start is happening, and all this 10,000 optimization of the function is happening, but this is the same function, so 100 containers going through the same phase and have in the end the same result. So why not go through this one time, store that stuff, and then for subsequent microservices with that function simply restore that? Yeah, not going through these heavy optimizations, only it takes time and resources. And this is kind of what this CRaC, this is Java project, this is open source project from Azul, and now you see Spring Boot support this and that, and this, and it just really, really gaining traction. But AWS uses it only for these hooks, and everything else is more or less based on the CRIO, because CRIO is on the operational level. They're just not interested in Java, not Java. They are doing that generally. And this SnapStart, you can enable it on the Lambda function. It's your decision. Individually on the Lambda function, it can be enabled, and it's simply in the configuration. You select SnapStart. This is some cloud infrastructure as code, like serverless application model. You can do this. Simply putting that you would like to have SnapStart, and that's it. Yeah, with that, you enabled AWS SnapStart, and that if you will deploy the function after enabling SnapStart for the next time, where during the deployment phase, the cold start phase will be going through, and then the snapshot will be taken. And then if you invoke it, the snapshot will be invoked. So the idea is that this snapshot invoking is much quicker as the cold start. Otherwise, why? Yeah. And that's only by enabling the SnapStart on the Lambda function. Now you see this is kind of checkbox, nothing else. Then cold starts are just cut in half with simply checkbox. I would like to have SnapStart on that function. Now we saw this optional hooks before snapshot and after snapshot. And I told you this comes from CRaC. And how we can use it to optimize further, because now we have 1.5 seconds. It's better than 3 seconds, but nevertheless, it's a bit more. Now we will think about what I told you about this dirty code to retrieve item with ID 0 and pre-warm Jackson in that situation. This CRaC enables you, this is the resource implementation, the resource interface. You need to have this dependency IO GitHub CRaC that you see. And then you have these two methods, before checkpoint and after restore. After restore, I don't use it very often, but before checkpoint, this is where you can put your logic. This is called priming, yeah, where you put this heavy computational logic, like get product by ID 0, just to warm up Jackson function. The beauty of this is that this before checkpoint will be executed during the deployment phase. That means that this pre-warming will happen with the deployment phase, and in the invocation phase, you already benefit because this is loaded. This is loaded into the snapshot that was created after priming. Yeah? And along with this, of course, not every application benefits from this. Yeah? Not every application has this something that is heavy, but this is what I calculated if I did this priming on this DynamoDB get item request. Above, there are values before priming, and after this, there are values after priming. And now you see this pure Java without frameworks. I'm even better than GraalVM with that. You see 300. P99 is 434 millisecond call start. It's very good, and you see Spring Boot, Quarkus, and Micronaut have higher call starts. You can optimize that with some quirks, because what costs time is translation from Lambda model without kind of using the framework to annotation model of Micronaut and Quarkus. This call is also costly. So I wouldn't go to this, but generally speaking, I could optimize it with the dirty code even further, and I was more or less sometimes less than a half second, sometimes above 1 second, half of the second. So comparable GraalVM calls comparable to GraalVM. There is one challenge currently. if you measure this cold starts, and you can measure this with AWS tools, there is a kind of computational bug that AWS, I would say, approved, that there are, I could, and several other people found that we cannot understand where 200 milliseconds came from, because we measured also end-to-end latency from, and then it was, yeah, why 200 milliseconds more? And they confessed that just there is a computational bug, and snapshot restore outside of the Lambda function is not shown in the graphs of AWS, and they add 200 milliseconds currently. So there is a bit, you need to also calculate this, but now I think, as I measured the last time, that was only 100 milliseconds, so they reduced it anyway, and then the thing will be okay. But for you, you need to measure the end-to-end latency. For example, API gateway receives the request, and API gateway sends the request back. This is the honest time that you can get. But nevertheless, currently SnapStart, it's general technology. They don't say it's only for Java, but currently it only supports Java. I think that also net people will benefit from it. They have the same problems, more or less. And it's just, if you snapshot with CRaC, there is nothing language specific there. It's just micro VM, container snapshot. It just doesn't matter what programming language. It should be, this snapshotting and restoring should be quicker as the cold start of the programming language, which is for net will be as well. So also deployment with the SnapStart in the deployment phase. Because, yeah, the container creation is in this deployment state. It also takes 2.5 minutes per Lambda function. Yeah, because this snapshot taking, and they store it layered, like Docker image layered, it takes time. If you deploy many functions within one deployment, they do it in parallel, so it doesn't add too much. So I measured with 10 functions, it wasn't 2.5 minutes, it was 2 minutes, 40 seconds. So it doesn't matter, but the same is with GraalVM native image. This is kind of, yeah, developer experience suffers a bit for the sake of being better in production. Maybe they can improve it or not. There is also one quick, is that if Lambda function is not invoked for 14 days, which is rarely, so it may be on the staging environment, but then you should think, why should I need a SnapStart there? Yeah, you can leave with the cold starts there. Then the snapshot will be deleted from the cache. Yeah, this is how they implemented this, just not to waste resources. And then if you then invoke the function after 14 days, which may happen, they will take the snapshot during the invocation, which will take 2.5 minutes on your lifetime, before, which is not acceptable. Anyway, so this is kind of the situation. Don't activate it on the function that have this pattern of invocation, but it's seldom. So I don't have too many functions that I need AWS SnapStart, and they are not invoked for 14 days. But there are some things that are not working. For example, for SnapStart doesn't support provision concurrency. Provision concurrency is when you say, I have newsletter at 9 o'clock, and at 9 o'clock I send newsletter to 10,000 people. You can pre-provision environments to that 1,000 of containers are there at 9 o'clock. So they are ready, that you don't have cold start, that are simply ready for this. You will pay for them. For all, if you don't use it, you will pay, but there is this provision concurrency. It doesn't work with the SnapStart now. It only works with x68 architecture, not with ARM. Probably not a big problem. You cannot bind NFS system like Elastic File System. I don't need it. I use S3 and all that stuff. So there are some limitations. I probably don't need them. So it's fine for me, but for some use case it may be not. And probably next time, from me, next steps, and I'm as a community builder, I give feedback to also to AWS people. So this priming logic that I showed you, this additional logic, it should be provided out of the box, like pre-warming heavy computational task like Jackson and so on. This should be done automatically. This should be recognized what services I use, and then kind of be behind the scene for me, because people write repetitive code. Everybody will write something, get item from DynamoDB just to pre-warm. You can have open source project just functioning out of the box for you. Yeah, so the situation is now snapshot is taken after in the deployment phase, so after one Lambda invocation. Of course, no C2 compiler optimization kicks in, so you don't have any benefits of C2. Maybe, and you need 10,000 invocations. Maybe for somebody who is really needing peak performance of the function, there should be the possibility to take the snapshot after the function is invoked 10,000 times during the deployment phase. Just if it's restored and you have the peak performance. It should be your decision. If you have these functions that are heavily executed, then maybe it can be done during the deployment phase. But of course, you need to fracture many parameters, like invoking 10,000 of functions can take time, and that will prolong the deployment phase because snapshot cannot be taken. And of course, it's the trade-off of the cost, because you need to pay for 10,000 Lambda invocations for pre-warming. If you don't need the peak performance, probably you don't need this. But maybe there are functions that really would like to benefit from all this C2 or client optimizations. Mainly it's it. I don't want to compare the services, GraalVM native image, AWS SnapStart. For me, I would start with AWS SnapStart, probably, because it's only checkbox, more or less, on the function level. Yeah, and think a bit about priming, because GraalVM native image adds this ahead of time compilation, it adds complexity. Yeah, so I will not start with that. I would try to go this managed AWS way to do this, and I will be pretty fine with that. Maybe for very, very picky Lambda functions, I can go then other path, but I'm a big fan of the managed stuff. And I'm pretty sure AWS will optimize SnapStart further for me on my behalf. Normally, it will be the last slide, but something interesting happened. Last month, AWS added something into the documentation of Lambda functions. And they called it proactive initialization. So what they added that sometimes we will see that the function is proactively initialized when I deploy it, even without SnapStart. It's normal function. Normally they don't pre-initialize. By pre-initialized, they mean go through the cold start phase, but not invoking it. Why they do this? They optimize their own resource consumption. So that's not, but this is kind of similar to this provision concurrency for which I pay, but I actively require it. This is here, they do it proactively, but they don't communicate when they are doing this. They are simply doing, and people started now to measure. Yeah, when they are doing it, and what they say, a lot of people measured that now what they observe since 1.5 months is that in between 50 and 75% of the cases there is a cold start. There will be no, because AWS now doing proactive initialization for you. Yeah, and you don't pay for this. There are warm containers waiting for you to be executed, more or less. What does it mean? So now you have to think, do you need AWS SnapStart and GraalVM at all? For example, if you say I previously had 1% of the function having cold start, which was not acceptable, now you have probably 0.25 or 0.5% of the cases, because in other cases there will be pre-initialization for you. So maybe now the amount of this cold starts is so low that you say you can live with that without SnapStart and without GraalVM native image. It's just up to you. So with this proactive initialization that is not guaranteed and you don't know really, but the people measure and they come to those results, AWS simply lowered amount of cold starts, which is also a good stuff. And it doesn't depend on the programming language at all. They simply optimize their own consumption. So now it becomes interesting how to play with that stuff. Maybe you don't need this optimization, but I think it's a good thing to have choices. Now you can measure first. Now, for me, the second option will be AWS SnapStart, because it's easy. It's more or less checkbox on the function, and you can go with that. And GraalVM native image will be then the third one if you just say, okay, I cannot optimize via priming anything, and with the GraalVM native image, then I will have probably the best results. So that's more or less it. I know it was probably for people not dealing with AWS Serverless on the daily business a bit heavy stuff. But anyway, I hope you enjoyed it on the Sunday morning. And I will be happy to answer your further questions. You took a lot of notes, I saw. Yeah, thank you. Are there any questions? No.
I just have one question about your how you test, because I saw you have several statistics about cold starts. Can you enforce a cold start, or you just measure when there is a cold start?
Enforce, of course, if I redeploy the function, the first invocation will be cold start because the old execution environment is thrown away. It's just the new code. It needs to be downloaded. It will be the new stuff. And you can measure this. There is a CloudWatch service, and it gives you the query for statistic, and it shows you. So I simply did a load test, 20 minutes with 100 execution per second. And when they give me that I have 50 cold starts, more or less, and I see the time. So, of course, the official way to measure the CloudWatch query insights is the log insights is the service that gives you where you had warm executions, where you had cold executions on all the times. So the question was how can I measure cold starts and whether I can enforce it. Yeah, I can enforce it if I don't call my Lambda function for 3 hours. The guarantee will be that the first execution will be the cold start. And if I do the load test with 10, I have 10 executions directly, then all 10 will be the cold starts. No warm environments. The first 10, for example, there will be for sure.
Thank you. I didn't expect that there were so many cold starts. If you keep busy, then.
Yeah, of course, if you have steady workload, so you just have 10 executions. So the first 10 will be cold starts, and then you reuse the environments. But it's not the general pattern how it works. Yeah, in the night you won't have anything, then containers will be released. Then in the morning, people will come. So this is our photo service. We have European customer, nobody orders in the night. And they come after the work, more or less, and they start working with our system. So you have the spiky workloads nearly all situations. Other questions? Okay. Then I would say thank you very much. So if you can find me, if you have questions, then simply ask me. I have some GitHub project where I explain how I measure this, so I can provide you some information. It's also how you can deploy it in your AWS account if you would like to play with it. Okay, thanks. Yeah.